Good afternoon. I'm Frans van Heerden and we'll be discussing geography this afternoon. When we discussed the different factors that influences the climate of Southern Africa, I think it was quite clear that during winter months and summer months there's different things that are at work that determines the climate. And this afternoon I want to talk about the winter weather patterns. Nkuli, if you can help us there a little bit. Obviously there's a massive difference between the weather that we experience during summer and the weather that we experience during the winter months. We're heading for winter now, and what are the main things that you can remember that we discussed in terms of cyclone activities when it comes to winter conditions over Southern Africa?
A high pressure.
Yes.
A high pressure moves down from the northern sides, and it dominates over the interior.
So that comes down a little bit more to the south. Okay, I'm glad that you mentioned that because you are 100% correct. I think you're referring to the Kalahari high pressure system. But I just want to make this quite clear to you and to all the people that are sitting there that the high pressure, can you remember, we often mention that it's an anticyclone. Can you remember that? So just again, if I can quickly show you. We said that a high pressure system is the H. Can you remember that? And when we say the H, then if you can use your imagination to see that this is an H, and we close it at the top, it forms an A, which means that it becomes an anticyclone. So I remember the H and the A goes together. So anticyclone and high pressure systems go together, but the A also stands for what kind of movement?
Downward movement.
Yes, it is downward movement, you're right. And it also means that it is anti-clockwise. Remember the A. The A for anti-clockwise and the A for anticyclone. And then it becomes a D for downward movement. And then we said that the cyclones are often referred to as low pressures, if you can remember. So we say that it's easy to remember because the L can easily become a C. If I do this, and then it means my low pressure becomes a cyclone, and it also tells me what kind of direction it is. It is upward direction, and it is what kind of direction? Is it clockwise or anti-clockwise? It's clockwise. The C tells me that it's clockwise. Well done, Nkuli. So you've just made one mistake there with your answer, and that is you described the anticyclonic action that determines our winter patterns. But there's another cyclone that we find that reaches the southwestern Cape during winter months. Can you recall the name of that?
The mid-latitude cyclone.
The mid-latitude cyclone. Well done. And I often say to people that geography is logical. Tell us something that is logical about the name mid-latitude cyclone.
They form in the middle latitudes.
Fantastic.
And that is between 30 and 60.
Well done, Nkuli. And if you hear the word cyclone, it means it is?
Clockwise rotation.
Clockwise rotation. Well done. You've answered well. You can see that if you understand the basics of this, it's easy. Because you just need to know the difference between anticyclones and cyclones, between low and high pressure systems. From there on, you can add the rest of the material and it becomes easy. If we take a look at the winter conditions, do you recall that picture there? It looks like the weather forecast, doesn't it?
Yes, it does.
Yes, it does. I think I've taken it from there as well. And what you'll see there is I've indicated, for example, the two high pressure systems. If I can just quickly show you the two high pressure systems. Let me just get a pen there. I had the highlighter, that doesn't quite work. There's my one high pressure system, can you see? And there's the other high pressure system. Those are the ones that you were referring to. And then you also mentioned that there's a high pressure system that dominates there. Is that correct, Nkuli?
Yes, sir.
And that is where I find my Kalahari high pressure system. This one that I find along the west coast is referred to as my
South Atlantic High.
My South Atlantic High. And the one along the east coast?
The South Indian High.
The South Indian High. Well done. But you've also mentioned something interesting. You've mentioned that during the winter months, their position changes. And I think if you take a look at the arrow there, you'll see that it is closer to land and it is further north during the winter months. So that means during the summer months, these systems move downwards. Remember, the sun also shifts down, and that is why all these systems move further south. But during winter months, because the sun actually moves further to the north, these systems tend to migrate to the north as well, and that is why they're further north in winter months. Here's our friend the mid-latitude cyclone. There you can see. Now, Nkuli, help me quickly. How do you know that that is a mid-latitude cyclone?
It is moving. It is approaching the Western Cape. It's moving from the west to the east.
Well done. It's moving from the west to the east, which is a dead giveaway of a mid-latitude cyclone in terms of the winter conditions, yes?
And I can see the cold front arm of it.
The cold front. You mentioned the cold front. Now, that's very interesting because mid-latitude cyclones consist of two fronts, basically a cold front and a warm front. Now, how do you know that that's a cold front, Nkuli?
It has triangles and not circles.
So you are talking about those little things there that are triangles, and when it is the warm front, they are semicircles. Fantastic. I can see you really listened when I explained this in class. When we talk about the mid-latitude cyclone, Nkuli has already given an idea that it moves from the west to the east, and it moves over Cape Town area. Now, this is the Cape Town area that we're talking about, this section here. And when we take a look at that Cape Town area, during which season do they get their rainfall, Nkuli?
During the winter season.
During the winter. Now, why do they get winter rainfall and we get summer rainfall?
In the Cape Town region, they get cyclonic rain. No, they don't. They get frontal rainfall, and then we in the interior get cyclonic rainfall.
You are almost there. At first you were right. They do get cyclonic. Cyclonic and frontal is the same, remember. But I'm glad that you made that mistake, because it is nice that the learners can know that we get cyclonic and frontal. Remember, frontal is the front and cyclonic means it is a low pressure system. So it's a low pressure front that brings the rain. So yes, you're right. They get cyclonic rain, which only comes during winter. And in the interior we get convection rain. There, now you've got it. You see, sometimes we get a little bit confused, but the bottom line is never panic. You didn't panic. You thought, you know what? If that's not the case, I know what the right answers are. So well done, Nkuli. You are right. We get convection rain here in the interior. So for convection rain, we need...
you need low pressure.
Yes, and the temperature must be?
We need high temperatures.
High temperatures. And that we get during summer months. So that explains why the interior of South Africa receives summer rainfall. Well done. If we can move on to the part of the mid-latitude cyclone again, you'll see there that it indicates in the orange arrow the mid-latitude cyclone. Remember, MLC in this case just stands for mid-latitude cyclone, is further north than in summer. This is important to remember, that the mid-latitude cyclone during summer months can still pass here, but it passes south of the country. So does that have any influence on the weather in southern Africa then?
The Butala said the Cape region doesn't get much cyclonic rainfall in the summer months.
Exactly. So the bottom line is, because they are further south, it means that they don't really have an impact on our weather that we find over South Africa. If we take a look at the next picture regarding winter conditions, there's a word there called inversion. Can you recall what that is?
It means like the opposite. It's lower, it's downwards.
Yes, so it's the opposite. What do we usually get when air rises, Nkuli?
As air rises, it usually cools down.
It cools down, well done. And that, if you want to know how to remember that, is so easy. Remember that mountains get snow on top of the mountain. That means as the air rises, it cools down, and at the top of the mountain I get my snow. You don't get that at the bottom, you get that at the top. Just think of Kilimanjaro. We did that in grade 10. for those people that can still remember their grade 10 work. In grade 10 we said that Kilimanjaro, situated right on the equator, is covered with snow at the top there because of the fact that it's so high above sea level. But as the air rises, it cools down. Now, what happens with inversion is it is literally the opposite. It's almost as if it changed in complexion, in character. And during winter months, you'll see that the inversion layer is relatively low. Can you see that, Nkuli? Now, if the inversion level is low, how does this impact on moisture that comes from the Indian Ocean that wants to get to the interior? Will that stop the moisture from going to the interior?
Yes, the moisture from the Indian Ocean can't go through the inversion layer, so there's no moisture for the interior. So there's no rainfall in the interior during the winter months.
Fantastic. I couldn't have explained it better. And the reason why the inversion level is lower during winter months is because of the fact that the high pressure system dominates the interior. And because the high pressure system dominates the interior, can you remember? High pressure, anticyclone, downward movement. The downward movement, as you can see in the arrow there, the blue arrow, actually points towards the inversion. That means that it pushes down on the inversion layer and it keeps the inversion layer lower down so that it doesn't rise, and because it doesn't rise, there's no way that the inversion level can rise, and because the inversion layer is situated so low, there's no moisture coming in. During summer months, I find the following. I find that the high pressure system is not as dominant anymore. And all of a sudden, my inversion layer rises. And the net result of this is all the moisture from the Indian Ocean can move to the interior and we can have rainfall over the interior. Do you remember that?
I remember that.
Will you remember it in the exams as well?
Definitely.
Okay. Let's move on to the next slide then. We're coming to berg winds. Now, Nkuli, we often say that geography is easy because it's logical. Explain to me how berg winds is logical.
Berg winds are logical because they form on top of the mountains, and it's when the air warms up as it goes down the slope of the mountain. Fantastic.
And what in that name tells you that a berg wind originates at the top?
The berg part.
The berg part, because the berg part is the name berg in Afrikaans, and berg is mountain. Is that correct?
Yes, it is.
Okay, and which is also the same as the mountain, like in Taba, for example, Tabanshu. Okay, the mountainous area. So if I've got my high pressure system over the mountainous areas, then the wind will come down from a high pressure to the low pressure. Why does it blow from a high to a low? Can it blow the other way around?
If there was a low pressure in the interior, it would. But now there's a high pressure dominating the interior, and the low pressures at the coastal lows. So the air now moves from a high to a low, so it moves down the slope.
So what you're saying is that there's a law, like the law of gravity, that says that things can only fall from the top to the bottom. If I can just find a highlighter here, let me show you. There we go. If we take a look at this and we simulate what happens with gravity, gravity means it can only fall from a high to a low. It cannot fall from the low back to the high. So the same thing happens here. There's a law that governs these things, that wind can only blow from a high pressure system to a low pressure system. So it can't blow the other way around, except if my high was all of a sudden at the sea and my low is situated at the mountaintop. And that means that a wind always gets its name from where, Nkuli?
From the direction from which it blows.
Fantastic. It gets its name from the direction from which it blows. So if you hear the word berg winds, it blows from the berg. If you hear the word sea wind,
it blows from the sea.
It blows from the sea. If you hear the word land breeze,
it blows from the land.
It blows from the land. If you hear the word valley breeze,
it's from the valley.
It's from the valley. Well done, Nkuli. You see, geography is logical. Just think. So if we take a look at this, you'll see how the air literally moves down, and as it moves down, I think what is important is that the temperature increase. Now, if you think of a temperature increase, help me quickly, what will happen to the surrounding areas? For example, if I'm a farmer there in Cooley and I've got this massive land and my cattle is grazing in that vicinity, they obviously need the grazing land, and this wind blows down, the temperature increase, what will happen to the veld itself?
If it's in the winter seasons, then it would cause the veld to be dry.
To be dry. And if it is dry, what can we expect from there?
You can experience veld fires.
Veld fire. So I must take caution in order to try and stop that. Okay, so or I must try and just be on the lookout for those kind of things, perhaps educate people about that so that they don't start fires in that area, or that they're just aware of the fact that it is dry conditions during that time. You did mention berg winds and you did mention winter. Now I want to just point out that berg winds usually occurs during winter months. So those two things go together, and remember we are busy with winter conditions. Now when we talk about berg winds, it's interesting that berg winds will only stop to blow if there's berg wind conditions as soon as my mid-latitude cyclone reaches the berg winds. So that is when the berg winds will cease to blow. But remember, it leads to hot and what's the other thing that we've got?
Dry conditions.
Dry conditions. Yeah, at the bottom because of the temperature increase. Okay. This is just another synoptic map that I've got for you here in Cooley. Now, this thing, obviously, I mean, is dominated by one specific weather pattern. Help me with that. What's the biggest thing you see on this?
I see, so am I looking at
what's the biggest weather pattern you see here?
The mid-latitude cyclone.
The mid-latitude cyclone. Well done. People often refer to it as a cold front. It is not. Nkuli has already indicated that this section with the triangles, look at that, triangles, those are my cold front, and these with the semicircles that you see here, they are the warm front. So it literally has got two legs, the cold front and the warm front. But you can go back to the mid-latitude cyclones and you can again go and study that, and you'll see the two fronts. But the system itself is referred to as a mid-latitude cyclone. Now, if the South Atlantic high moves in behind the cold front, very cold conditions with even snow and heavy rain can spread to the interior. And that is why often we get this extreme cold conditions over the interior here in the Free State and Cooley. So you can explain that to your dad now. And then what's also interesting is that I find my berg wind conditions here. As you can see, there's a coastal low pressure system situated there over the Eastern Cape. There you can see there's Port Elizabeth. And I see my high pressure system dominating this over the Kalahari region. There you can see there's the town of Uppington, which is close by to the Kalahari. So my high pressure system sits there, and then I've got berg wind conditions that blow from the high pressure system to the low pressure system, which is the berg wind conditions which you just described. These are typical winter conditions that you see on the synoptic map. And then this is something that we referred to a little bit earlier, and I want to show you this quickly. This is the summer condition, and we're not going to focus on that now. We are busy with the winter condition, but I think what is nice in this is just to take a look at the difference between the summer and the winter conditions. Now, here's the high pressure systems that Nkuli has spoken about. There's my South Atlantic high pressure, there's my South Indian high pressure, and there's my Kalahari high pressure system. You can see them. But look at the summer conditions now and take a look what has happened to the South Atlantic. In summer, it's way to the south. There's my South Indian one. It has moved further down south as well. And what you also notice in this is during the winter months, I find my mid-latitude cyclones, it's those low pressure systems that I've circled there, I find them that are moving in over the interior. While during summer months, they are much further to the south. They're not even close to the land, so they don't have an influence on what we experience there. You see two mid-latitude cyclones in the winter conditions here in Cooley. Is that an anomaly? Let me use another word. Is that the exception, or is that the norm that you often find these grouped together?
It's normal for mid-latitude cyclones to come in families, so to speak.
Fantastic. They come in families of, can you remember how many?
I'm not, I think.
3 to 4. Yeah, well done. 3 to 4. And that's the families that they usually come in, and they group together like that. So this is the family that you see at the bottom, and the one over the country is obviously the oldest. Can you see that? Okay. So I hope that you can see how these high pressure systems literally migrate between summer and winter, and that you can see that it's got a massive influence on our weather patterns over southern Africa. Then, Nkuli, I think most students will pay attention at this, because this shows you some of the questions that were asked in the previous exams. Sorry about that. It's just examples of it. And obviously, I mean, they can ask more than this. They can cover different angles, but it will give you more or less an indication. So the first question was, what will happen if the mid-latitude cyclone moves towards a coastal low? Can you remember the coastal low there where we had the berg wind conditions? And when the mid-latitude cyclone moves to my coastal low, it weakens my coastal low. So it's important to remember that my coastal low is weakened by the fact that the mid-latitude cyclone moves towards that. And then how a front is formed, and I think for you to understand that, you must understand what the front is. And the front is a separation between
two air masses.
Two different air masses, like hot and cold. Well done, Nkuli. And also it can be temperature, but it can also be density. And sometimes temperature, most cases in geography, temperature and density goes hand in hand with one another. And then to identify the different fronts, you need to take a look at the map. Can you remember the synoptic map that we had up there? So if you get a question like that, identify the different fronts that you can see there, like the cold front or the warm front. But you need to have the map in front of you. Then the temperature regarding a specific place. Again, here you need to either see the graph, or you need to read this from the synoptic map. We did discuss this at some stage when we did the mid-latitude cyclones, where we had the weather station, and then there's two temperatures given. The one at the top was the air temperature, and the one at the bottom was the dew point temperature. Please remember that. It is not like the weather report that you see on TV, where it is the maximum and minimum. It is the air temperature at the top and the dew point temperature at the bottom. Well done. And then the high pressure movements associated with high pressure systems. Remember, we said high pressure system, anticyclonic movement, downward movement. Can you see? Downward, and another word for downward is subsiding air. It sinks. You can also use the word sinking air if you remember that easier. Then the sectors, identify the warm or cold sectors on the map. Again, here you need to take a look at the mid-latitude cyclone, identify the fronts, and then take a look at the cold sectors and the warm sectors. Those are the masses that are either behind them or in front of them. And we did discuss this when we did the mid-latitude cyclone, when we said that you use the triangles and then you just make an arrow from there so it indicates where the cold air comes from, and the cold air moves in a specific direction. The South Atlantic high that you needed to identify there, always remember that is along the west coast, the South Atlantic, and then my South Indian will be along the east coast. And then explain why air of the South Atlantic high is dry and cold, because South Africa lies in the band of high pressure systems. And remember, high pressure means it is subsiding air, that means it is dry, and because of the fact that we are situated roughly round about between 22 and 35 degrees south, it also means that we've got relatively cold conditions in southern Africa during winter months. And then identify the South Indian high. That is so easy. You just need to look at the map and you find that along the east coast. Well done, Nkuli. And then regarding berg winds, the season that the berg winds occur, we discussed that. That's during winter months. And then the weather conditions that you experience, remember we said it's dry and it's hot. Then explain why dry and hot conditions occur during berg winds. It is because the air descends down the mountain, it heats adiabatically. That just means that it heats more or less at 0.65 degrees Celsius per 100 meters as it goes down. Then we set the environmental hazards of berg winds as is dry and hot conditions that can lead to veld fires. You can recall that. And then answer this one quickly, Nkuli. Which weather system will terminate berg winds or will bring an end to berg wind conditions?
A mid-latitude cyclone.
A mid-latitude cyclone. Well done. And then what are the environmental hazards and what can be done to reduce the impact?
Fires are a very serious problem, runaway fires.
Fantastic. And what can we do to just reduce the impact that this has?
You can warn people and you can educate them about the dangers involved with runaway fires.
Brilliant. And then how does berg winds affect the coast of South Africa? It means that the coast of South Africa becomes dry and hot. Often you find this along the KwaZulu-Natal coast and along the east coast. You do find that this along the west coast as well. But a place that is renowned for this is the Queenstown area, where they find these hot berg wind conditions during summer months. I remember as a youngster when we played sport there, it became almost unbearable during winter because of the hot conditions of the berg winds. And then during which season does it happen? It happens during the winter season. Well done. And that concludes our chapter on the winter conditions. We will continue with summer conditions. So, yeah, I hope you enjoyed this session. And please go and study the winter conditions. It is easier than you think.